These sheets are from Chapter 7. They're online. Print them, don't print them. I know most of you probably have this stuff memorized. So if you've kind of forgotten it, you might want to revisit it. I have all the pages will be on this file as well, so you can print them here. But you need exact values in this chapter. So we're back to doing some work with exact values. Make sure you get revisited. Now, if I tell you no calculator, sine of 15, yeah, we're kind of crippled by that. Oh, wait, Armor can do it. Pi over 12, right.
Yeah.
What's that? By 2. But remember, sine's not linear, so if you divide the 30 by 2, you're not going to get a linear relationship between the signs. Remember, it's that curve. So we're going to have to derive how are we going to be able to do this. And then, again, we learned 345. How are we going to handle something like a 345? Do we really want to work with 345? Cosine of what? Cosine. Remember, when you whip all students take calculus on this, really? Here it is. If we do this, and work here, where else is the cosine the same? Quadrant 1. So what's the reference alpha for 345? 15 degrees. So we will be able to handle the 15 a lot easier than the 345. Right? So we'll come back and look at these. Remember the right triangles, 45, 45, 90, and the 30, 60, 90. We're just reviewing these from your geometry and from what we did in Chapter 7. So this page is just how do we get to the quadrants? We have alpha, 180 minus alpha, 180 plus alpha, and 360 minus alpha. These will help you with your 45s. Here's your 30, here's your 60. All the big 3 trig ratios are there for you. Like SOHCAHTOA. And then here's the unit circle in radians, if that helps you. This is all review from Chapter 7. I just copied all that stuff that we did and just pasted it right here for you. Okay? Anybody have anything you're not clear on from these? Everybody? If you don't remember it, you need to go back and get it. Okay? As we just talked about, cos theta is going to be the same as cos of the opposite of theta. Cos theta and cos negative theta. If this is theta, this is negative theta, we're going to be in either quadrants 1 and 4, or if theta is big enough, it'll send you over to quadrant 2, and then negative theta will put you into quadrant 3. So either way, the cosines will be the same. Whereas the sine of theta and sine of negative theta will be opposites. Quadrant 1 and 4, everyone's positive here, but the sine's negative in 4. Sine is positive in 2, negative in 3. So that can help you also. If you like to work with your quadrant 1 angles, that's the way to go. You just have to realize if I'm working in quadrant 1, what's the relationship between the quadrant 1 and quadrant 2 or 3 or 4 angle that you're trying to do. Again, all review from what we did back in Chapter 7. And I think we even talked about these things. Any questions on those two? I'm scooting through this kind of quick just because it's all review. So now, let's talk about the idea of, well, if we have a 15 degrees, can't we just take 30 divided by 2? That's not going to work. But what will work is maybe taking 2 angles in adding to get 15, or 2 angles in subtracting to get 15. And we're going to look at subtraction first. So I have 2 points, point A here and point B here. And I have the 2 angles labeled as beta, the angle point B, and alpha, the angle for point A. So the angle in between these 2 points, the rays made by the origin, is going to be the alpha angle minus the beta angle. That's this reddish colored angle in between. And so I connected across from point A to point B and just put that arbitrary connection there. Now we don't know where A and B are, it doesn't really matter. But remember, point B is going to be cos beta, comma sine beta, and point A is going to be cos alpha, comma sine alpha. That's the unit circle. So we're looking at a unit circle here. You know it's unit circle because this is 1, 0. So what we want to do right now is figure out the distance from A to B. And we're going to do it in a couple of different ways. Now my suggestion to you right now is to put your pencils down and just watch. I'm not going to ask you to derive, but I'm just going to ask you to kind of watch the journey and see the 2 places we end up. Because there's 2 places that we want to go to get the length of AB. And once we have those 2, then we're going to be all set in being able to figure out the measure of alpha minus beta. That's where we're ultimately going. How can we figure out the measure of this angle? All right. So these formulas are going to be derived from the distance of segment AB. We're going to use law of cosines, and we're going to use the distance formula. The bottom line is, really, you just need to have these memorized. They're just more identities. So first one we're going to look at is the distance formula. So the distance from point A to point B, using our distance formula, you guys all remember this, where you have x comma y and x comma y for our 2 points. So cos beta minus cos alpha and sine beta minus sine alpha for the difference of the y's. And when you square these binomials, the big thing to look at is what happens in yellow and what happened in green. Because what do we get with cos squared plus sine squared beta? 1. And then cos squared alpha and sine squared alpha give us another 1. So I put those in the front of this radical. And then we have minus 2 cos beta cos alpha, minus 2 sine beta sine alpha. If we square both sides and combine the 2 1s, we get this mess right here. The distance squared from A to B, the distance of AB squared, 2 minus 2 cos beta cos alpha, and 2 sine beta sine alpha. So we're just going to use that in a minute. We're going to set it equal to what we get when we find the distance squared using law of cosines. So again, non-important for you to derive it, just important for you to see it. Using law of cosines, what's the distance from here to here? Without using law of cosines, you should already know this distance. 1. How do you know that? Radius of the circle is 1. So this is 1, which means this is 1. Now what we're looking at is the triangle AB, and we can call this a C if you want. In triangle C, C is the origin. If we use law of cosines to find the length of this side AB, AB squared is going to equal 1 squared plus 1 squared, side plus side, minus 2 times the adjacent sides, cos the included angle, which in our case now is alpha minus beta. If we work this out, 2 minus 2 cos alpha minus beta, also equal to AB squared. Same thing we got right here. AB squared equals this mess. AB squared equals this mess. What's the logical conclusion? Set them equal to each other. So if we do that, we take these 2 ideas and set them equal to each other right here in blue. And again, what we're trying to do is figure out alpha minus beta and work them together. So if we isolate cos alpha minus beta, okay, and put this 2 over here, the 2 disappears. You have negative 2 cos beta cos alpha minus 2 sine beta sine alpha. if you divide everybody by the -2, we get cos beta cos alpha plus sine beta sine alpha, and that is the cosine of the difference of two angles. So cos alpha minus beta, any two angles, is going to equal cos cos plus sine sine. That formula you want to memorize. So this right here, we're going to have that is the cos of the difference of two angles. The cosine of alpha minus beta is cos cos plus sine sine. Now obviously alpha and beta, it doesn't really matter which order you put them in this problem, in this identity, but there's going to be some situations where it does. So if you're going to do the cosine of 15 degrees, and we need exact values, your objective is to figure out how can I change cosine of 15 degrees into something that's a difference between two angles that we know the cosines and sines of. Right? Yeah, 60 and 45, those are angles that we really like. We like working with them because we know their values. So cosine of 60 minus 45, based on our formula, again, we're looking at cos cos plus sine sine. So cos 60 times cos 45 minus the sine of 60 times the sine of 45. Now, all of the ones on the right, we have exact values for. Oh, plus. My bad. Sorry. So cos 60, cos 45. What's cos 60? If you're stuck with this, you go back to the triangles if you have to. You pull out your cheat sheet right now if you have to. But you've got to know these. Cos 60, 1/2. Don't let her mess with you. Cos 60 is 1/2. What's cos 45? The square root of 2/3/7/9. Just pick any numbers, it'll be fine. All right. So cos 60 we said is
1/2.
cos 45. You're warm. 1/2. The sine of 60 is square root of 3/2, and sine of 45. You want to go with that?
Yeah.
All right. These are radicals.
What is that in radians?
Radians. Well, if we're in radians here, you're going to want to be in radians here. So this ends up being √2/4 plus √6/4. And when you add those, you get √8/4, right? No, huh? What do we get? Or √2 plus √6, either way, over 4. That's the cosine of 15 degrees, exact value. Making them up is not going to be very effective. We want to go with the exact values. What? As 15 degrees? Yeah. Do you want to switch to radians just for fun? Oh. Yeah, and if you look, back to that first page, if you print those out, it gives you, now on this one, it's only, here we go, it's only giving you the main three. But there's another sheet that we printed that gives them all to you. So use them, don't use them, it's totally up to you. Okay? So here's the formulas that you want, and we can derive other ones, but we've kind of shortened this up and said, look, this is the cosine of the difference of your angles. This is the cosine of a sum of two angles. And some people, rather than do two different formulas, they just condense them. It doesn't matter, whichever way you want to remember the two different formulas. One for cos sum, one for cos difference. Look like your hand when you have holding a calculator with that. Here's the sine sum and difference formula. So sine alpha, sine beta, sine alpha plus beta, sine alpha minus beta, and then all in one shot. If you want that, there they are. Okay. So notice I'm spoon feeding you right now. I'm throwing the formula right with what we're doing here. So we're looking for you to go, what's sine alpha minus beta? We'll do this one together, and then you can try one of these. So sine of 15 degrees. How are we going to get the sine of 15 degrees using a difference? Well, very similar to what we've already done, right? What are we going to do? The sine of 60 minus 45. Okay, what else could you do? What if you didn't want to use the 60 and the 45? You could do 45 minus 30. So let's just do that for fun, just to break it up. The sine of 45 minus 30. Not that it matters, because it doesn't. So if we're going to do the sine of 15, you can do sine of 45 cos 30 minus cos 45 sine 30. And again, you're totally dependent upon your ability to recall these exact values. What's sine 45? Root 2 over 2. Cos 30. Root 3 over 2. Cos 45 and sine 30, 1/2. So again, very similar to what we did, because you're using same values. This time you get root 6 over 4 minus root 2 over 4, which becomes, so that's going to be root 6 minus root 2 all over 4. And that's the sine.
It doesn't matter.
Okay, so if we're going to do 285, the sine of 285, that's not a 5, is going to equal the opposite of the sine of what? 75, which is going to be the opposite you want to do 45 and 30?
Yeah.
So sine 45 cos 30 plus plus cos 45 sine 30. So what is the sine of 45 again? Root 2 over 2. Cos 30, a half. Cos 45 in sine 30, a half.
Cos 30 square root 3 over 3.
So you don't want to use half cos 30?
Square root of 3 over 3.
Okay. You got to be careful, and it's going to be that fast. You're going to be powering through. I know you did. I know you were just doing it because we talked about it before class so that we could use that as an example. When you power through too fast, that's what can happen, and you won't catch it. Yeah, we planned that. So that's going to be the opposite. You're going to get root 6 over 4 plus root 2 over 4. But don't forget, you've got to distribute this negative. So when you're done, you're going to get negative root 6 minus root 2 all over 4 for the sine of 185 degrees. Do all the work on the yellow one. If you need extra, go on the back. Questions on that? Okay. So now we're going backwards. So they're asking you, do you know, if I gave you this side of the identity, what was the angle that you were working with? And again, we're kind of spoon feeding it to you here. And you're just matching it up, and hopefully, oh, Mr. Moore did these without math type. So alpha and beta, what are alpha? What's alpha? 50 and beta. So this must have come from cos 50 plus 10, cos 60. Yellow, and do all the work. If you need the back side, just do them on the back. Okay, otherwise, if you have room, I did them all on the front. And then cos 60. Cos 60. One half. Yeah, you could do 30 plus 30, but geez, cos 60 is one of our guys. All right? Somebody mentioned earlier, whoa, are we going to have to be doing this with radians? We love radians. It's just something you need to go back and revisit. The longer you take to do this, the more like your Chapter 7 results this will be. If you don't remember how that went, you might want to go online. Okay? So, we're matching up again. We've got the sum, alpha plus beta. So what's alpha? Over. So what's alpha, what's beta? Alpha is the 5 pi over 12. And beta, 1 pi over 12. And we're adding them. So you end up with 6 pi over 12, better known as in the new math, pi over 2. You're having a day, aren't you? So sine of pi over 2. Yeah. Okay. Now you need to understand. That I'm not giving you these formulas with these questions. Yeah, you would think, but there are people every once in a while that come up and say, "You didn't give them on the quiz. You put them on the notes. What the heck?" I didn't know we had to memorize them. So they're not going to be on the quiz, they're not going to be on the test. You got to memorize it.
Will they always do like that? Or they work out?
Yes, we're not going to give you ones that don't work out. It's kind of pointless. See ya. Have a great weekend. Thanks for coming. All right. What are they telling you about alpha right here? Thank you. It's in quadrant 1. Jeez, Arushi. We have to be looking at alpha being here because you're between 0 and pi over 2. What else are they telling you about alpha? It's got to be in radians. Okay? What do you know about beta? Quadrant 2. Okay, so this right here is beta. So you need, why are they telling you these things? Because it affects what happens up there. Okay, we know that if I tell you sine alpha is 4 over 5, what do you know about alpha? Only one thing. What is it that you know? That sine alpha is 4 over 5. What's the only thing you know about alpha? Just from this? Just from this statement, sine alpha equals 4 over 5, you don't know that it's in quadrant 1. It's in quadrant 1 or 2. So we know that because all students take calculus, puts positive signs in 1 and 2. All we know is this is positive. This is why they have to tell you alpha is in quadrant 1. They have to force you into one of 2 quadrants. Sine of beta is positive. They're telling you beta has to be the big angle in quadrant 2. Okay? And you're trying to find the cosine of alpha plus beta. Let me just throw it in there. So if you're doing this, you want to go ahead and draw your picture and say, look, if I'm in quadrant 1 and the sine of alpha is 4 over 5, how long is this side right here? 4. How long is this? And then the missing side? 3. So now you know all the sides, which will allow you to find sine, cosine, and tangent as you need it. This one's a little bit harder. We have to draw this triangle, and we're looking at sine of beta. This side is how much? 5. This side is, now be really careful, this side, negative 12.
Oh, yeah.
Because in quadrant 2, you're going left and up. So it's 5, 13, those are the positives. This is the one that has to be negative. So if we're going to do cos alpha plus beta, what's the formula? Minus cos minus sine sine, according to Arushi. What's the cosine of alpha? Look, 3 over 5. What's the cosine of beta? Negative 12 over 5. Minus sine of alpha, 4 over 5. sine of beta. Is there a mistake and you're not sharing?
Just get negative 12 over 13? Or...
Probably.
Okay.
I keep relying on Arusha. She's closest. She told me today. So negative 36 over 65 minus 20 over 65, negative 56 over 65. That's cos alpha minus beta. Who can tell me the measure of alpha? Nobody. Not exact value, you can't get it. You could get an inverse and get the approximate value, but again, we're not asking for that. We're asking for cos alpha plus beta. So this is a show. My recommendation, as it was earlier, is to not touch the right-hand side, the negative cos x. And you want to make sine of 3 pi over 2 minus x. And you want to see if you can turn that into a negative cos x by, for starters, doing sine of 3 pi over 2 cos x minus cos 3 pi over 2 sine x. What's the sine of 3 pi over 2? Negative 1 times the cosine of x. What's the cosine of 3 pi over 2? 0 times the sine of x. And 0 times the sine of x is 0, so this is equal to negative cos x. Everybody follow that? Now, the next example, you're going to be tempted to do the wrong thing. And you need to be strong. When they're passing out the drugs, you need to say no. No, no. I know they're free, and I know it'll be really good, but no. Well, the first time, they got to book you. Your temptation might be to say, oh, cosecant x. Ooh. You know what we can do with cosecant x? If we flip the cosecant, we get... We got to get the duct tape for this one right here. When you flip, when you take the reciprocal of the cosecant, what do we get? Sine of x. And then you could take the reciprocal of this. That's going to be what you're tempted to do. Start with this. Secant pi over 2 minus x. Okay? If you're dealing with the secant, you can do 1 over the cosine of pi over 2 minus x. Don't worry about the cosecant side. Leave it alone. But you have to remember you are dealing strictly with a fraction here with the 1 on the top. So that means when you simplify, it's 1 over. 1 over 0 times cos x plus, what's the sine of pi over 2? Times the sine of x. That's going to give us 1 over sine x. Just go secant x.
You're telling them for this thing.
So don't touch the right-hand side of these, only touch the left side and make it work and turn into the right side. So hands off on the right-hand side of these. Anybody not following what we're doing? Now, I know you're rusty, okay? But you need to go back